Cells have several different ways that they can resist heavy metals that might harm them. These mechanisms vary from cell to cell, but overall there are 5 main mechanisms that cells can use.
The first of these mechanisms is the efflux pump, which maintains the homeostasis of metals and bacteria. The bacteria uses ATP to push out toxins through the pump.
Another mechanism is intracellular bioaccumulation. Metallothioneins in bacterial cells pull heavy metals all over to one side of the cell to prevent it from spreading to the rest of the cell.
Another mechanism is extracellular sequestration. In this method, exopolysaccharides come out of the cell and attack metals to keep them outside. The exopolysaccharides bind to or confine certain toxins or metals to keep them separated from its own biological system.
Surface bioabsorption is another method for bacteria to resist heavy metals. This is where the cell wall keeps the bacteria out of the cell. The outer layer charge helps accumulate the metal on the outside of the cells and make it too big to come in.
The last of these mechanisms is bioprecipitation. This is where specific enzymes in the cell interact with heavy metals outside of the cell to make them insoluble so that they can no longer enter the cell. Because these metals can no longer enter the cell, they accumulate on the outside of it and can recover and recycle.
Let's talk a little bit more about the most common mechanisms for bacteria to resist heavy metals, the efflux pump. Efflux pumps are typically composed of a cytoplasmic membrane pump and a periplasmic protein and an outer membrane protein channel.
When the cell senses that there is too much of a compound other than its natural substrates, such as metals or toxins, inside it, it triggers the start of its active transport out of the cell. Because naturally diffused into the cell, the use of ATP is required to move it against its concentration gradient and out of the cell.